focus on creating the Azure application gateway related resource using Terraform and then associating that respective resource to the VMSS virtual machine skill sets. Okay, so now let's go and then understand that practically. So this part, whatever is there, Azure application gateway, its equivalent resources, now we are going to use Terraform and then create it. So we are in our GitHub repo 27 Azure application gateway basics using Terraform, and as part of this previous section itself, when we are implementing the Azure application gateway using portal, we already reviewed the AG subnet and energy, whatever is required for this respective application gateways. So which is C601 VNet input variables, where we have added two input variables. One is AG subnet name and then AG subnet address. So we created a dedicated application gateway subnet for this respective application gateway related resources. Its equivalent variable values in Terraform.ef bars, which has the subnet IP address space as 10.1.51.0/24. And in C607 AG subnet and energy, we already know that we have created these resources related to AG subnet related security group, and subnet and security group association, and also created the network security rules for that respective subnet. In addition, as we are not in need of Bastion host, we have commented all the Bastion host related configurations. So moving on, so the core focus here is going to be on C901 application gateway input variables and C902 application gateway related resources. So let's come back here and go to 27 Azure application gateway basics, and inside that in Terraform manifest, so we will enter into the section C901 input variables placeholder file. And in C902 we will define our application gateway resources. So the first resource we are going to define is the frontend IP. So if you remember, so for this respective application gateway also, it needs a frontend IP, so which you can call it as LB public IP. So AG LB public IP or whatever, right? So that public IP related resource. So this resource we have created it multiple times. So I am not going to specifically write using live template writing. And in addition to that, so we are also going to use a simple locals block with some variables defined here. So with some naming conventions, which is required for the application gateway related resource. So what are those? So in my application gateway, I need the front-end port name. So example, it is 80. So for the front-end port, that information, and front-end IP configuration name, listener name, and then also when we create a request routing rule, so at that point of time, request routing rule 1 name. So all these things will be having this way. So we'll append the VNet name completely -FE port, which is nothing but front-end port, okay, and front-end IP, HTTP listener, and request routing rule 1. So these are generic variables. And in addition to that, if we are going to add multiple apps, okay, so this is like app 1, right? So for app 1, if you see here, backend address pool name for app 1, and HTTP setting name for app 1, and probe name for app 1. So these three things become the app specific ones, okay? So BEAP, backend backend application pool with app 1, and backend HTTP setting app 1, backend probe app 1. So this is for app 1. So why we are defining it for app 1 specific, why we are appending it with app 1 is, so in our next demo, we are going to focus on app 2 also. What is app 2? So app 2 also will have the app 2 related VMSS virtual machine scale set with app 2 related web server installed. And then we will also implement the context path based routing using application gateway. Then /app1, when the request comes to /app1, should go to app1 VMSS, and request comes to /app2, go to app2 VMSS. So those things also are going to be in place in the upcoming demos. So accordingly, this naming convention is arranged in that manner. So these are generic, and in addition to that, we are going to have for app 1, this is the settings, backend address pool name, what it should be, HTTP setting name, what it should be. All these are name of the configuration blocks only, nothing, okay? So no specific criticality inside them. And just I appended it with Azure virtual network name, because it will have the HR hyphen, means like business division hyphen, environment hyphen, VNet name, and all that information. So that's the reason I have added this, okay? So if you want, you can add something else here also, that's fine. So now let's come back and start defining the resource. So before defining the resource, you can go to that respective resource, which is nothing but Azure RM _ application _ gateway. So if you see here, inside that, you can see they also defined a locals block and then defined equivalent values here: backend address pool name, front-end port name, front-end IP configuration name, HTTP setting name, listener name, request routing rule name, and then redirect configuration name. So we have arranged it little bit in a different order, where how we need it in our use cases in a detailed manner. So instead of combining all those things in a group. And now if you see here Azure RM application gateway, so it will have multiple blocks defined inside that. You can see here there are multiple blocks. So what we are going to do is we are going to implement this step by step instead of taking this directly and then putting and then using it. So we are going to write each and every block by understanding them. So let's start with defining the application gateway resource here. So I'll say control space and resource and Azure RM underscore application gateway. And my name of this gateway is going to be web underscore AG. And here three things are common. So one is name. So name as usual we will provide it with dollar, right, in double quotes we will put it local dot and we'll go to C3 locals and get the resource name prefix exact name. So it is resource name prefix. And in addition to that we'll also add something called hyphen web hyphen AG. And another thing is where this respect to application gateway resource to be created. So which is nothing but in which resource group. So we already know. So in which resource group it need to be created? Azure RM resource group dot rg dot name. So you can reference that by going to that respective C5 resource group, Azure RM resource group dot rg dot name and rg dot location. So here the next thing is in which location it need to be created. So even that one we are going to add it here, okay, which is location. So these three things once completed, so we'll add all these things inside the block so that we can add one after the other. So the first thing here is start and end. So inside the start and end we are going to define the SKU, which is nothing but which standard version our respective application gateway is going to use, and also define the auto scaling for the same thing. So for that purpose, so we are going to have something called SKU related block, and inside that you will have two things. One is name of your SKU, so which we will provide it as standard underscore v2 and the tier, okay. So this one you can directly search here in the documentation, right? You can see here standard v2, standard web application firewall and web application firewall underscore v2. So we are using the application gateway of tier standard underscore v2. You can see here SKU block supports the following things: name, so whatever we have given, which is standard underscore v2, and next is tier. In tier also we are using the standard underscore v2, and capacity, the capacity of the SKU to use for this application gateway. And when using a v1 SKU, this value must be between 1 to 32, and when you are using v2 SKU it should be 1 to 125, and this capacity is optional if you use auto scaling configuration, okay. So now if you want to use capacity, then you can say capacity, and then you can use 2 or 3 auto scaling related instances it can create, or you can use them, means like it can by default manually create the couple of instances, 2 or 3 or how much. The max limit is till 125 for standard v2, but here we are going to use auto scaling. If that is the case, this capacity is invalid for us, okay. So which means we'll go here and control space and I'll search for the auto scaling nested block, right? So all these things are nested blocks, remember, which means you can automate these using, means like multiple auto scale configurations you cannot define so automatically, but you can see it here, the option here you can see it is a list only, list item it provides, okay. But now let's come back here and provide the values for it. So minimum capacity you can start with 0 and maximum you can go till 10. So we have 125 till we can go the limit, right, usually capacity, but we can go till maximum capacity we will define as 10. So exactly you can see here. So minimum capacity for auto scaling accepted values are 0 to 100 is acceptable, and maximum capacity 2 to 125 are allowed here, okay. So we have provided 10, we are in the limits. So the next thing here is once you define the SKU and then auto scale configuration, so next thing we need to focus on is gateway configuration, right? So gateway IP configuration. So let's search for this block, and inside this gateway IP configuration block you will have something called name and then subnet ID. See, gateway IP configuration block supports the following: the name of the gateway IP configuration, the ID of the subnet which the application gateway should be connected to, right? So now I will say name and I will provide the value as my gateway IP configuration, and it need to be connected to which subnet, okay. So for us this application gateway need to be connected to its own dedicated subnet, okay. So I'll say Azure RM underscore subnet dot, so we have created something called AG subnet. So let's go to that respective AG subnet and get the local name reference of that AG subnet, and provide it here and provide the ID of that subnet. So this is the gateway IP configuration block. So in our next lecture, we are going to focus on creating aggregation of application gateway resource till gateway IP configuration. So now we will define the front-end configs and also listener and also app1 config related backend tools, and then also the probes required for it and also the request routing rule. So let's start with the front-end configs. So when I say control space and then search for F here, we'll have two blocks shown here. One is front-end IP configuration and another one is front-end port. So we'll start with the front-end port, and inside that you will have something called name and also you will have something called port, right? So now we'll start with port and then I'll provide port as 80, my front-end port, and front-end port name. So the name of the port what I'm going to give here, you can see here, right? So front-end port name, this is the one. So this is the entire value, and what I'll do here is front-end port name, and I will say it here as local dot front-end port name, right? So now you can see name and port are created, and next block you can see here control space, and if I search for F, I have something called front-end IP configuration. So here you need to associate your public IP whatever you have created here, right? So that one you need to associate inside this front-end IP configuration block. So to start with, again we'll have the name, and another one we are going to have here is public IP address ID, right? So now the front-end IP configuration name also in the locals block we are going to have here. You can see here front-end IP configuration name. So I can say local dot front-end IP configuration name and public IP address ID. So we can go here Azure RM public IP dot. So let's come back here, right? Dot, and this is the one web AG public IP. There is this, and we can say dot ID. So now public IP address ID also associated. So this completes the front-end configuration, and this is the association to that respective subnet. If you see when we are creating the application gateway, it will ask for select the VNet, and inside the VNet select the subnet. So that part. So now we'll focus on the listener part. So in the listener part, so whenever we run the control space and search for H, right? So you will have the setting called HTTP listener, and inside this HTTP listener it will start with first thing is name, and name. So for the listener also in the locals block you have something called listener name defined here, okay? So you can say local dot listener name. So and next thing starts is in the listener we associate the front-end IP configuration, front-end port name, and then protocol. These are the information we provide in listener. So if you want, you can also verify the same thing here. HTTP listener block supports the following. You can see name, front-end IP configuration, front-end port name, host name, and then host names, and then protocol, require SNI, SSL certificate name, custom error configuration related information, and firewall policy ID. So far as important things here are, so name, front-end IP configuration name, front-end port name, and also protocol. So these things we are going to configure now. When we reach the SSL certificate related demo, at that point of time we'll use the SSL certificate name. And for custom error configuration, when we create the storage account with static website related pages, so at that time we will also implement this custom error configurations. So for now our focus is going to be on very few attributes here, so which is front-end IP configuration name it is asking for, okay? So the front-end IP configuration name is this one, right? Local dot front-end IP configuration name. So one way you can reference this way, right? And another thing here is after that the front-end port name also we need to provide, and you know that the front-end port name is local dot front-end port name. So now you can see the importance of using the local block here, right? So how you are defining, you have defined your names there, and then you are referencing them in multiple places, right? So that's the reason it is important to define a local block for this respective application gateway resource. So name, front-end IP configuration, front-end IP, front-end port name we have defined. So finally we'll also define the protocol, and from protocol perspective we'll go here and search for the protocol, and you can see here HTTP is the current thing which we are defining now. So this is good. So this completes the listener configuration. So the next thing here is app1 configs. So from app1 configs perspective, there are three things we need to define when we go for a specific app1, right? So if you remember, if we open that rule, right, so inside that we have something called, you can select the listener, and also you can define the backend related backend pool information, and also you can associate you can create a HTTP setting and then associate it, and also in HTTP setting we can define our probe. So now we need to define the backend pool, HTTP setting, and then custom probe. So these three things we will define now, and then after that we will define the rule, and then inside this rule we will associate the listener, and then these information inside this rule. So this picture is very important for us to understand even from Terraform perspective too. So if you remember, so we have defined the front-end IP configuration, and also we have defined the listener so far. So now we are going to focus on rule-related things, which is HTTP setting, backend pool, and then custom probe. So in the app1 configs, the first thing is backend address pool, and inside that name of my address pool I am going to provide. That's all. So backend address pool name, it is going to be present here. See, backend address pool name underscore app1. So if I provide that local dot that one, so it provides the hr hyphen dev hyphen vnet hyphen beap hyphen app1 as my address pool name. So I'll take this and put it here, local dot backend address pool name app1. And next block I'm going to create here is backend HTTP settings. So this is another important one. So if you go here, right, and then search for its settings, right, where is it? You need to go to that respective block. Oh, missing. See, backend HTTP settings block we are in now, and inside that we have multiple arguments. Okay, cookie based affinity cookie name of the backend HTTP settings, path, port, probe name, protocol, request timeout, host name, many things are present inside that. Okay, so let's start with one here. Okay, so let's come back here, and so we have defined the backend pool related block. Now we are defining the HTTP setting block. So now we will start with the name, right, and name, you know that we can get it from here, HTTP setting name app1. So I'll come here and provide the local dot HTTP name app1. And next thing is we will start with cookie based affinity, right? In cookie based affinity you can say enabled or disabled, so I'll say disabled. And next thing is, so you can define the path. Okay, so this is nothing but we have discussed about this when we are manually implementing it, override path. So if your backend is listening on some path like /app1, okay, and that need to be overridden for you when you access via browser. So which means whenever you access some abc.com, okay, and slash, so when you enable this path, anything present inside this app1 you can directly load them. Okay, so something like this. Okay, these index.html ideally present inside something here in index.html, but in browser you can directly access them as slash under the root context itself, because you have overridden the root context path with /app1 removed from the backend. Okay, so that's another important thing. So this one you can comment it, we don't need that. Okay, so we'll go ahead and then define the port. Backend port is going to be 80, and protocol, so which will get the information from here, which is HTTP, right? So wherever required the values, I am also taking it from documentation to ensure that there are no case sensitivity issues. Okay, so now the next thing here is after protocol, so we are going to have the request timeout, which is 60 seconds, and the probe name. Currently probe is not defined, so I will leave it as is empty, and later now we will define and then associate. Even though not defined, we know that our probe name is going to be this one, correct, right? So local dot probe name app1, so we can directly put it here. But how it is going to associate is once you define, so that probe name only you need to associate here. So the next thing here is probe, right? So why I got provisional here? Okay, you can see probe. So now for the probe also you can search for this block here, and see probe also has some values here, host, interval, name, protocol, all these things. Okay, so let's quickly define the probe now. So probe also starts with few things here, which is nothing but name and the host. So let me say name, and name we know that it is going to be local dot probe name app1, and next comes the host. If you remember, this one we have provided it as 127.0.01. okay, and next is it is going to have interval 30 seconds, and we will also have something called timeout, which is also 30 seconds, and unhealthy threshold we will provide 3. So 3 unhealthy health threshold related things. So it will wait for 3 failures, and then after that it will trigger the next steps of making that respective backend as down in the load balancer. So and the next thing is protocol, and for protocol we'll go and then get the value from here directly, which is HTTP, and we'll also have the port, which is 80, and we'll also have the path, so /app1/status.html, and another important thing is match block inside that. So wherein inside the app1 status.html, so if the body of that HTML, right, if the body of that HTML finds app1, so then make it as true. And status code also you can provide. Status code should be a list item and provide something as 200 like this. Okay, so now this completes the defining of the probe. So in this lecture we have defined the routing rule now. So inside this request routing rule, so we are going to associate the listener and also the HTTP setting and the backend pool. So let's come back here and say control space, and you can find something called request routing rule. And inside this request routing rule, this is a nested block, which means it is a list block. So multiple routing rules you can define, or multiple probes you can define, or multiple backend HTTP settings you can define, right? So now in the request routing rule, so the first thing it is name of that routing rule. And if you go on the top here, so you can find that here something called request routing rule 1 name, right? So that is the one. So let's come back here and say local dot rule 1 name, and here rule type. Okay, so let's remove this and I will say rule type. And if you search for this rule type in the documentation, right, so you can see in request routing rule you have two types of rules you can create, right? So one is basic and another one is path based routing. So in the next demo we are going to focus on path based routing, but now we will focus on a basic rule type. So I'll say basic. And next thing here is, so we already said that we are going to associate these things. Okay, so where is it? Here. So HTTP setting and the backend pool and listener. So let's start with inside this rule associating the listener, and after that backend pool and HTTP setting. So let's start with something called HTTP listener name. So let's get the listener name directly from here. So this is the local dot listener name, right? And so when we go to the advanced sections, when we use SSL, so the listener name, how we will change in our HTTP, in our locals block is listener underscore name underscore HTTP, listener underscore name underscore HTTPS. So this is a basic implementation. So we are doing this way. So when more and more components are coming, and then more and more blocks like this, routing rule blocks or listener blocks are coming, so the naming convention in the front end block, we are going to effectively manage it in a righter way how we need it. Okay. So now the next thing here is backend address pool name, and you know that backend address pool name is local dot backend address pool name app1. And one more we are going to associate is backend HTTP settings. Okay, so from backend HTTP settings, so let's come up here, and you can see here this is the local dot HTTP setting name app1. That's all. Okay, so now we have successfully also defined the routing rule. Let's go back to our GitHub repository here, and we completed the C902 application gateway related AG resource step 08, and step 09 is going to be associate this respective application gateway in your web Linux VMSS resource. So in the network interface block, using application gateway backend address pool IDs argument, so you are going to associate that. So let's go to our C703 web Linux VMSS resource. So nothing but you are making a connection between your load balancer and your respective VMSS resource. So if you go here, right, so you have created an application gateway load balancer, and you have created the VMSS, but these VMSS related backend instances, how you are going to associate, means like how these respective instances will be added to application gateway is by this respective setting whatever we are doing here. So in the network interface block, right, in the network interface block of web Linux VMSS resource, in the IP configuration block, I am going to say control space, and I can say application gateway backend address pool IDs, and here we need to provide our backend pool information. So if you see here, it is present here. So this is the backend address pool. So where it is present? Inside this respective resource, which is Azure application gateway, and these are list of backend address pool IDs, you can see, right? So set of strings. Okay, so now let's come back here and Azure application gateway dot and get the information web AG, right, dot. Inside that you have some block called, so let's come back here, backend address pool, right, and backend address pool dot, and you can see here it is going to be backend address pool dot ID. And so now if you see here, this respective backend address pool is a list item, which is a list item and it is a nested block, right? So which means this is the first backend address pool inside this application gateway configuration. So which means we need to say backend address pool of 0.id. That's the thing, and then save it. So now we have successfully completed this step, okay? So which is nothing but associating application gateway to VMSS. In the next step, which is step 10, C705 Web Linux VMSS auto scaling default profile, comment or remove the LB syn count related metric rules. So C705, right? And LB syn count related metric rule is already commented, okay? So we should be good with that step. And the next thing here is execute the Terraform commands. So in our next lecture, we are going to execute the Terraform commands and then verify the stuff. So I'll see you in the next lecture. Until then, bye bye. Thank you. In addition to that, we can also see here, so we have also defined a simple output for this application gateway. So web application gateway ID and IP address associated with the web application gateway related public IP related IP address, okay? So that these are Terraform commands now. So we are in our terminal and we are entering into the section 27 Azure Application Gateway Basics, and inside that we are in Terraform manifest folder. So we will run the Terraform initialize, and once the local backend is initialized and then provider plugins are downloaded, so we'll run the Terraform validate, and after that we'll also run the Terraform plan. And once the plan is successfully printed without any issues on the CLI, so we'll go ahead and then run the Terraform apply auto approve. So we can see here our web AG related outputs also you can see here, and currently it is going to create 38 resources. So in the previous demo it is 36 resources, and now as part of the application gateway, so you added two more resources. One is public IP and the other is application gateway related resources. So total 38 resources it is going to create now. So I'll say Terraform apply and auto approve. One thing to remember when we are working with application gateway is it might take 5 to 7 minutes or sometimes 10 minutes to create this application gateway, even if we create via Azure portal or even we create via Terraform, okay? So I'll pause the video until all these resources, 38 resources are created. So we can see here all the 38 resources added successfully, and also you can see here it took close to 11 minutes to create the VMSS and close to 4 minutes to create the application gateway. So now we'll go back and then verify our resources here. So we are in step 12, verify resources, and we will verify the virtual network, web app, DB, Bastion, and then AG subnets. So let's go back to our virtual network, and inside that we can see that all the subnets got created and associated with their respective security groups, network security groups. So you can see here web subnet, DB subnet, Bastion subnet, app subnet, and then AG subnet. So now we'll go back here and then also verify the VMSS instances, auto scaling, and then topology. So let's go to virtual machine scale sets, and in HR dev web VMSS, so we can see it has currently 2 instances created, and in networking also we can review the topology if you want to. So wherein all the subnets in the virtual network will be shown, and in addition to that the instances wherever it has created, those also will be shown in detail in the topology. So let's go back here and also review the scaling policy. So we have removed or commented the LB syn count related metric rule. So currently we have only percentage CPU greater than 75 and then less than 25 related metric scale out and scaling rules, and available memory bytes related rules which are specific to this respective VMSS resource. And next thing here is we will verify the Azure application gateway now. So let's go back to home here and go to load balancers, and we'll click on application gateway, and HR dev web AG got created. And now if you see, everything we have created using Terraform only. So let's go inside that, and some backend health is still not available, so we can go here directly to backend health and wait for the backend health to become online. So let's wait for it and see what will be the response here. So it is saying that body of the backend's HTTP response did not match and received invalid status code from another server. Maybe the things are getting provisioned inside those things, which means like it will take 5 minutes to provision all the things in those VMs. So after that only we can see the healthy state on the load balancer. So let's go back here and then cross check our probe here, and it should have the value as app1. This is good, okay? So now let's wait for these things to become healthy. So we'll give them 3 to 4 minutes time. So after once your resources are created, why? Because the last provisioned resource is your respective virtual machine scale sets only. So give 5 to 10 minutes after you see this apply resources completed, and then only move on to verifying your resources. So at that point of time, everything should be successful. So we can see here, now it is successful. So we can refresh and one more time also check it. Success received from both the web servers present in our virtual machine scale set. So let's come back and click on the overview and then refresh one more time to ensure that no errors shown here. So that's good. Again we'll refresh here and click on that web AG. So everything looks good here, and we'll start with reviewing one after the other. Okay, so in the configuration tab, standard v2 capacity is auto scale, minimum instance count 0 to maximum 10, and HTTP to disable. The same whatever we have configured here, correct, right? So auto scaling related configuration 0 and then 10 and then standard v2. And we didn't touch anything related to web application firewall, and we'll go to the backend pools. So you can see here HR dev vnet-deap-app1, and inside that our VMSS got added successfully. And next thing is HTTP settings, so HTST-app1, and inside that you can see the cookie based definitely connection draining all are disabled, and backend protocol is HTTP and backend port is 80, and all other things request timeout seconds we have provided as 60, and path value we didn't give anything, override backend path, so it is empty. So and the custom probe it has associated with the probe, and it is HR dev vnet be probe app1. So we can go to health probes here and then verify the same thing. And if you want to test this probe also, you can click on test and then it will again call your backends and then verify if it is successful or not. So just for our testing, we can also run that test and then see if our probe testing is successful or not. So you can see status is good for both servers. Okay, so now let's come back here. So these are the settings whatever we have provided via this respective probe block here, and all those things were populated here. Okay, so now let's close this and go back to the rules, which is the very important one. So inside this rule, you can see that listener it is associated with is HTTP listener, and backend targets you can see backend target is DEAP app1, whatever you have seen in the backend pools, and HTTP setting also HTST-app1. So they are associated and successfully looks good from all the configuration perspective. So in listeners also we can verify HTTP listener got created successfully, and its equivalent rule also associated here. And listener type we have given as basic, and no error page configuration we have done, and we have also associated the listener with the front end IP and then port as 80. So everything looks good here. So now we'll go here to overview tab and we'll take this information and access it in the browser. So you can see we are getting the response from our backend, and in addition to that we can also access app1/index.html, and also we can access other things like status.html, and we can also access something like metadata.html, right? So everything is accessible via HRDev web AG related public IP address. So the next thing we need to focus on is destroy our resources. So I'll go here and say Terraform destroy auto approve. So let's wait for all the resources to get destroyed, and after that we'll move on to the next demo. We can see here all the resources got destroyed successfully. It took close to 10 minutes to destroy all the resources. So we will remove also the provider plugins here.